Hi friends, in this video, let us analyze the time and space complexity of the bubble sort algorithm. In the previous videos, we have learned what is bubble sort and how to implement it. Let us analyze the time complexity first. Let us assume the array size is 5. Let us see the best case first. The best case will be when the array elements are already sorted. And for the outer loop, when I equal to 0, the inner loop will have 4 iterations. That is, for j equal to 0 to size minus 1 minus I. That is, 5 minus 1 minus 0, which is 4. And each time, this if will be checked. That is, 4 times it will be checked. But in no iteration, the if will become true. So no swap operation will take place, so flag will not be set to 1. And when we check the flag value, it is still the same, so we can understand we have already sorted elements, so break out of the loop. So for size equal to 5, we had 4 iterations, that is size minus 1 iterations. And if size is equal to n, then we will have n minus 1 iterations. And n minus 1 and n are polynomially the same, so the best case time complexity is order of n. So that was the best case. Now what about the worst case? Let us see. For the outer loop, when I equal to 0, the inner loop will be executed for 4 times. That is for j equal to 0, j equal to 1, j equal to 2 and j equal to 3. That is from 0 to size minus 1 minus I. So in the first iteration of outer for loop, the inner loop statement executed 4 times. Next, when I equal to 1, the inner loop will be executed for j equal to 0, j equal to 1 and j equal to 2. So in the second iteration of the outer for loop, the inner loop statement will be executed 3 times. Next, when I equal to 2, the inner loop will be executed for j equal to 0 and j equal to 1. So in the third iteration of outer for loop, the inner loop statement executed 2 times. Next, when I equal to 3, the inner loop will be executed only 1 time, that is for j equal to 0. So in the fourth iteration, we had the inner loop statement executed for 1 time. Next, when I equal to 4, this condition will fail and the outer for loop will stop its execution. So when size equal to 5, the total time taken t of x is equal to 1 plus 2 plus 3 plus 4, which is size minus 1. So in general, when size equal to n, t of x equal to 1 plus 2 plus 3 plus etc. plus n minus 1. That is the sum of natural numbers from 1 to n minus 1. And we know that the sum of natural numbers from 1 to n is equal to n into n plus 1 divided by 2. Here, the last number is n minus 1, so we can replace n as n minus 1 in this equation. So we will get n minus 1 into n minus 1 plus 1 divided by 2. And this minus 1 and plus 1 will get cancelled. So this will become n minus 1 into n divided by 2. That is n square minus n divided by 2. So we got the time required. Now how to get the time complexity here? Just find the degree of this polynomial and here it is 2. So we have the worst case time complexity of bubble sort algorithm equal to order of n square. So that was about the time complexity. Now let us do the space complexity analysis. And space complexity is the total amount of space a particular algorithm takes to produce the output. So here, array ARR takes n units of memory and size will take 1 unit of memory. And in the next statement, we have I, j and flag and each will take 1 unit of memory. So total space S of x equal to n plus 4. And here the degree is 1. So the space complexity will be order of n. Now let us discuss about the auxiliary space complexity. And as we learned, auxiliary space is the extra space or the temporary space used by an algorithm. Here, array ARR and size are given inputs. The extra memory used by the bubble sort algorithm is for I, j and flag. So 1 unit of space for I, 1 for j and 1 for flag. So total space equal to 3 units. So that was the auxiliary space used by this algorithm. So we can say the auxiliary space complexity of bubble sort algorithm is order of 1 since the total auxiliary space is a constant. And as we already learned, if a sorting algorithm sorts all the elements without using any extra memory or sorts all the elements with auxiliary space complexity as order of 1, then we can call that sorting algorithm as an in-place sorting algorithm. And here, the bubble sort algorithm can sort all the elements with auxiliary space complexity equal to order of 1. So we can call bubble sort algorithm as an in-place sorting algorithm.